Okay, hi everybody. We're working through the Math 31 limits review. This is question 1K. Just got to evaluate the limit here. And if I evaluate the limit, if I plug the 1 in, I'm going to get 1 over 1 minus 1. Well, that's an undefined. Okay, this is, as I'm approaching 1 here, this is actually going to go to an infinity. But if I go over here and go 1 squared minus 1, again, that's 1 minus 1, that's 0. Again, as I'm approaching 1, I'm going to an infinity here. So really, I'm getting infinity minus infinity, if you will, which is an indeterminate form. So I got a little bit of work that I got to do. And actually, I'm gonna do this down here because I'm gonna slightly, instead of coming straight down, I'm gonna move over a little bit. So this will be the limit as x approaches 1. What I really need to do here is add these two fractions together to get a single rational expression. Okay, so that's 1 over x minus 1 minus 2 over x minus 1 x plus 1, because I notice that the denominator there is a difference of squares, which means that my common denominator here will be the x minus 1 x plus 1. So this will be the limit as x approaches 1 of, and this will be x minus 1 x plus 1. The factor that was missing here was the x plus 1, so I got to put that in the numerator or denominator. So it'll become x plus 1 minus 2. I didn't really need to do anything to the numerator in the second term. But this will become the limit as x approaches 1 of x minus 1 over x minus 1 x plus 1. And now all of a sudden I can see, look at that. That factor will cancel with that factor. This is now why I wanted to give myself a little room. I'm going to come back over here. So this will now equal the limit. Maybe I should come down a little further so it doesn't look like those two run right into each other. This will now become the limit as x approaches 1 of 1 over x plus 1, which is true so long as we state that x cannot equal 1. Okay, I mean, those two will cancel out, but if x is equal to 1, then this becomes 0 over 0, and I can't allow that. So this limit right here is equal to this one, as long as we state that x can't equal 1, but that's okay, because I'm only taking the limit as x approaches 1. Plug the 1 in, and we get 1 over 1 plus 1, or a limit of 1/2.